Hello everyone, welcome to mytutor.ng. In this video, I'll be teaching on the topic machine. So what is machine? A machine is a device that allows you to apply a little effort in order to overcome a heavy load. So by definition, we are saying that a machine is any device that allows a little effort applied at one end in order to overcome a resisting force at another end. So a machine is a device that allows an effort applied at one end to overcome a load at another end. So we have defined what a machine is. Any device that allows a force applied at one end to overcome a resisting force at another end is called a machine. The force that is applied to the machine is called an effort. So the terminology we're defining is effort. So effort is the force applied into the machine and since it's a force, effort will be expressed in the unit called Newton. While load is the resisting force or the force that needs to be overcome by the machine. So the next terminology is load. So load is the resisting force that needs to be overcome by the machine. So we have defined what an effort is and what a load is. So what are the examples of a machine? An example of a machine includes a wheelbarrow. We have plier, we have pulley, we also have an inclined plane. So these are examples of a machine. The next thing we're going to be discussing is the mechanical advantage of a machine and the velocity ratio. So what is mechanical advantage of a machine? The mechanical advantage of a machine is the ability of a machine to overcome a heavy load by the application of little effort. So the ability of a machine to overcome a heavy load by using little effort. So any machine that can overcome a heavy load by using a little effort is said to have a high mechanical advantage. Mechanical advantage is also called a force ratio, which implies that is the ratio of the load to the effort. So by definition, we can say that mechanical advantage is the ratio of loads to the effort. So we say that mechanical advantage is the ratio of the load to the effort. So mathematically, we can say that mechanical advantage, MA, is equal to load divided by effort. The load is expressed in Newton, and also the effort is also expressed in the unit Newton. So we say that the load is expressed in Newton and the effort is also expressed in Newton. What does it mean? If we are given a question and the load is expressed in kilogram, then we need to convert it to Newton with the expression that the force F is equal to the mass times acceleration. So we know that force is equal to mass times acceleration. So if we are told that a load of 50 kg was applied to a machine, then we need to convert the 50 kg to Newton by using this formula that F is equal to mass times acceleration. So our force, which is our load, will now be equal to 50 times 10. Our 10 is the acceleration due to gravity, which is a constant. So 50 times 10 will give us 500 Newton. So what it implies is that the load is 500 Newton. So the unit of our load must be in Newton. Also, the unit of our effort must also be in Newton. Remember, I said earlier that our mechanical advantage is also called a force ratio. So our MA is called a force ratio. So if we're asked to calculate the force ratio of a machine, it then means that we're asked to calculate the mechanical advantage of the machine. So what is velocity ratio? Velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. So velocity ratio by definition is the ratio of the distance moved by effort to the distance moved by load. So that is the definition of velocity ratio. The ratio of the distance traveled by the effort to the distance traveled by the load. So mathematically, to calculate the velocity ratio, our VR, then velocity ratio will be the distance moved by effort divided by the distance moved by load. And since it's a ratio, it has no units. So in the next section, we're going to be discussing about the efficiency of a machine. So what is the efficiency of a machine? The efficiency of a machine is the ratio of the useful work done by the machine to the work put into the machine. Efficiency of a machine is expressed in percentage. So mathematically, the efficiency of a machine is equal to the work done by the machine divided by the work put into the machine times 100 over 1. So we're saying that the efficiency of a machine is the work done by the machine divided by the work put into the machine times 100 over 1. The work done by the machine is called the work output, while the work put into the machine is called the work input. So it means that the efficiency of a machine is equal to the work output divided by the work input times 100 over 1. If you recall, the work done is equal to the force times distance. So the work done by the machine, which is our work output, is equal to the load times distance moved by the load, while the work put into the machine is equal to the effort times distance moved by the effort. Therefore, our efficiency will be equal to the load times distance moved by load divided by effort times distance moved by effort times 100 over 1. So that's our efficiency. And when we look at this last formula, we can see that load over effort is our mechanical advantage, and distance moved by the effort and divided by distance moved by the load, this is a reciprocal of our velocity ratio. Therefore, we can now say that our efficiency is equal to the mechanical advantage of a machine divided by the velocity ratio times 100 over 1. So this formula is the formula we're going to be using to solve question when asked to solve question involving efficiency of a machine. That the efficiency of a machine is equal to the mechanical advantage divided by the velocity ratio times 100 over 1. A machine that has an efficiency of 100% is said to be a perfect machine or an ideal machine. But we know that there is no perfect machine, that there is no machine that has an efficiency of 100%. This is due to the fact that work put into the machine, some of the work that is put into the machine is used to overcome the friction by the moving part of the machine, and the remaining work put into the machine is now used to overcome the load. That is why the efficiency of a machine is not 100%. So we're going to see some examples involving efficiency of a machine, mechanical advantage, and velocity ratio. So we have a question on the board. The question says, a machine whose efficiency is 80% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if its velocity ratio is 4. So to solve this question, we will start by writing out our parameters that we are given. The question says a machine whose efficiency is 80%. So the first parameter we are seeing is the efficiency, which is equal to 80%. It's used to lift a load of 1000 Newton. We have load, which is equal to 1000 Newton. Calculate the effort put into the machine. We're asked to find the effort that is applied into the machine if it has a velocity ratio of 4, and we're given the velocity ratio to be equal to 4. So these are the parameters that are given in this question. Now we're asked to find the effort, but in order to find the effort, we need to calculate, or we need to find the velocity. We need to find the mechanical advantage of the machine, because we know that mechanical advantage is equal to our load over effort. So to get the effort, we need to know the mechanical advantage. We already know the load to be 1000 Newton. So to calculate for the mechanical advantage, then we need to use our formula that efficiency of a machine is equal to the mechanical advantage divided by the velocity ratio times 100 over 1. The efficiency that was given is 80%. So 80 is equal to our mechanical advantage divided by a velocity ratio, which is 4, times 100 over 1. So to calculate for the mechanical advantage, our mechanical advantage will be equal to 80 times 4, when we cross multiply, divided by 100. 0 can cancel 0. 2 can divide our 4 to give us 2. 2 can divide 10 to give us 5. So that will give us 16 over 5. So 16 divided by 5 will give us 3.2. So we have gotten our mechanical advantage to be equal to 3.2. Then we need to find our effort. So if you remember, our formula says that mechanical advantage is equal to load divided by effort. If we make the effort the subject formula, that will give us that effort will be equal to the load divided by mechanical advantage. And our load is equal to 1000 Newton divided by our mechanical advantage is 3.2. So we now have that our effort will be equal to 1000 divided by 3.2, which is equal to 312.5 Newton. So this is how to solve this question. This is how to calculate for the effort that is applied into the machine. So this is how to solve question involving efficiency of a machine. So in our next video, we'll be discussing on the types of machine. So if you have enjoyed this video so far, I would like you to click on the like button and don't forget to subscribe to our YouTube channel in order to get notification whenever we release our next video. So see you in our next video.